hit that go live button. And we're live. So, as I said, a journey into space with Jez Higgins. And excellent. The font hasn't loaded. Excellent timing on that. So just a quick intro to a few upcoming events we've got now. React Lean Coffee #2. First of that was in the real world and went really well. Roundtable Lean Coffee style. So we all vote on topics and go around the room, chat them through. Following that up with effective communication in the workplace, real versus virtual. Some of you may have met Amy at NordevCon. She came along, she was doing Lego. You may remember her from that. But she'll be talking about communication now in the face of ever-present remote working. We've got more in the pipeline. Satanic, Laravel, a digital investigation team focus with Norfolk Police, should be interesting. Virtual Social Club, excuse me. Virtual Social Club every Friday, 5:30 as usual. Goes on till quite late. Record has been 5:30 AM, but you obviously don't need to join us for that ridiculous length of time. Just drop in, say hi. Discord, as ever. The links are all over our social medias, all over the YouTubes. Join us, chat with us. Got questions or want to just share something? By all means, do. Fantastic. And as always, I'm going to get out of the way and pass on swiftly to Jez. Thanks, Jez.
Go on in. Or do I just need to yell at you?
Journey into space.
So, it's very self-indulgent. Welcome to Journey into Space. Hello, my name is Jez Higgins, and as the sound effects fade away, it's my pleasure to welcome our many listeners, not just in Norwich, but around the world. Sorry, I've always wanted to do that Nicholas Parsons thing. It's very self-indulgent of me. We're going to take a journey into space and also through time. And we're going to start by traveling back to a significant cultural event of 1982. Oh, now my thing's not working. I've broken my own thing. Oh, hang on. If I do that, there we are. Toya's Brave New World. The only single from the Changeling LP well, I know why, actually, because it's a good album. But anyway, we could think about the Falklands conflict. We could think about the Hyundai Pony. Was the first Korean car to be sold in Britain. That went on sale in 1982. Bobby Robson taking England manager job and bringing a crushing end to Ipswich Town's brief few years as a proper top flight club. Or perhaps even the first publication of The Secret Diary of Adrian Mole, aged 13 3/4. We could spend some time on all of those things, but of course, I'm actually talking about the Sinclair Zx Spectrum. Oh, hello, Sean. Can you sort that out for us? Thank you, mate. So 1982 was the year that the home computer revolution really kind of kicked off. So it began a couple of years earlier with the launch of maybe the ZX80, which was the first affordable home computer. I'm using affordable in a very loose sense there. It was under 100 quid just, but that wasn't, pocket change. There were other machines available like the Acorn Atom, and that would cost you about 170 quid. It's quite significantly more. But both of those were a fraction of the $1,200 that you'd need for an Apple II. That's about 4,000 quid now. So if you thought Apple hardware is expensive now, that is nothing to the 1982 prices. Sorry, the 1980. So the ZX80 was succeeded by the 81 in March of the next year. That'd be 1981. And that cost 70 quid. So you're already seeing kind of significant downward pressure on prices. But 1982 was just like the Cambrian explosion of home computers, right? So there was the BBC Model A and Model B, that was they were December 81, and I'm still going to count them. And they were for the posh kids because they were like 300 quid. And there was a Commodore 64 and the Dragon 32 and the Oric 1 and Jupiter Ace and the Computers Lynx and the New Brain. There was all these computers all came out in the same year. It was just crazy. And for me anyway, the big beast, the significant one, and the one all your friends had. If you lived in a small village, well, not all your friends, some of your friends, but if you lived in a small village in the middle of Norfolk, it was this thing. It was a Sinclair Spectrum, which cost £125 if you had the 16K model, and 175 for the 48K, the grown-up version, the 48K version. This picture here is actually the second edition, or the second revision, because it's got slightly darker keys, these blue keys. The first edition was much lighter. Anyway, so what happens is your dad inherits some money from his maiden aunt, and in an uncharacteristic fit of generosity, lets his 3 children have a bit of a treat. And my recollection is, and I'm sure this is wrong, my recollection is that I got a new bike, and my brother Rick got a 12-inch black and white telly, one of the ones with the twirly knob that you had to put a coat hanger in the back of. And as I remember it was my youngest brother, Ali, who wanted a computer, but he was only 6 then. So I think I got that wrong. But anyway, somehow or another, my dad cut the mail order coupon and sent off the money. And after some months, this thing arrived. And you unpack it and you plug it into the big telly in the lounge, and you go, okay, what do I do with this? And nobody really knew. Like, what were computers actually for? Right? They were in all the papers, but what were they for? And you didn't use them at work. We were kids anyway. We didn't go to work. We went to school like kids do, and they didn't use them at school. There was business software, but we'd never heard of it. We never heard of VisiCalc, which was what was driving the sale of those massively expensive Apple IIs in America. Actually, VisiCalc was the first spreadsheet, and Excel still replicates bugs from the original VisiCalc it was released in 1979 or something. So this computer thing, it wasn't going to help with your homework. But here it was like a genuine miracle of modern technology. It's about that size. So obviously we just played games on them. And games that we bought and games that we typed in from magazines. And there were like 1 million magazines, and they all had listings for you to type in. Let's see if this is going to work. Here we go. This is one of my favorites. Popular Computing Weekly. This is like 35p. Absolute bargain. And this is Miss Mac had this in our school library, and that's how I got to read this every week. There's no way I could afford 35p every week. So we've got some news there. Look, important stuff about the launch of, I don't know, ROM cartridges for the Spectrum. That was a bit of a disaster, really. Oh, hang on, that's the wrong thing. Sorry. And then we've got more stuff, readers' letters. Even people back then were pedants from the off. Lots of adverts for stuff, exciting listings that you could type in yourself, assuming, of course, you could read this. The sort of cheap newsprint letterpress printing, combined with, in this case, the Sinclair printer, which was about 4 inches wide, and it had this kind of metallized paper. The paper was covered with like aluminium, and it worked by scorching off the aluminium. So you finished up with a shiny silver printout with black poor resolution kind of black text on it, which then you're trying to photograph and then print on low quality newsprint. It's not ideal. But anyway, we typed this stuff in anyway, and we squinted at it and we typed it in. And we read all the pages of this ridiculous bloody magazine. We read, you know, there's an interview with Jeff Minter, not very revealing, unfortunately. We used to love Jeff Minter. Some games reviews. Here's an exciting program for your BBC, I think it is. A text adventure for you to type in. Some machine code listing there. This is an exciting look because the BBCs are boring because they're all to do with education. So this is a thing to plot the orbits of the inner planets. It's very worthy, the BBC. So there was that. And my other favorite magazine was this one, Your Computer. This is again, this is from December '82, and this is absolutely fantastic. Look at this marvelous cover photo here. So this is, if I can find the right page, let's go 15 seconds, a little bit earlier. Let's go. Here we go. I'll find it in a minute, promise. Here we go. Game Special, ZX Spectrum Flight Simulator. Look at this. Rod Hopkins applies his knowledge of multi-million-pound pilot trainers to produce the most realistic simulator ever published for a home computer, providing you're entirely happy to fly on instruments. I typed this bastard thing in. Look at this bloody hex listing there. Absolutely tedious, and you know. So we typed all these magazines in, and they were, you know, the listings are rubbish, right? And the games were rubbish, but we kept on doing it. And as we typed those programs in and we played those games, you kind of, you know how children learn to speak just by hearing other people speak? Well, that's how we kind of acquired, I don't want to call it programming, but that's how we acquired like BASIC. And after a while, eventually, you start to think, well, you start to take your first kind of little fumbling steps, you know, and you think, well, maybe if I do this, and then perhaps if I do, well, that, let's see, I don't know, that one maybe. I'd say, well, is it Y first or is it X first? Let's use Y first, I think, because it's backwards from what you expect. So maybe if we, you know, nope, that one. And so, okay, so that, you know, and we gradually kind of picked stuff up. The Spectrum had this really weird, compared to other things. So it had, obviously, we programmed it in BASIC, but you didn't type in for print there. I'm not typing in print. There's just like a single keystroke. And the weird thing is that even though I'm using like a conventional keyboard, it's all still there in my fingers, which is quite alarming, really. So we can say there, no, then, no, let x minus 1, let's say that. And then we'll just, I don't know, we'll go back to the beginning. And we can run that and see what happens. There's my A. If I press Z, oh, I don't know what's happened there. But anyway, we start to discover stuff, right? And that's gone wrong. But eventually, we kind of worked our way through it and we fumbled our way through it. And we would write our own games. We played them for a few minutes, maybe took a tape in at school and showed your friends, and then you wrote another, and then you wrote another, and then you wrote another. And over the course of like sort of 2 or 3 years, I must have written like 50, 60, 100 different games, shooters and maze games and vertical scrollers. And I even had a crack at a couple of text adventures. Epic Odyssey across South Norfolk to borrow Page's Honda C50, and they were all still pretty rubbish. The only one I remember of any of my friends was a version of Centipede that my friend Scott wrote. And if you look at Centipede, you've got like this sort of segmented thing, and it's running down the screen like this. And he in order to make it kind of playably quick, he got rid of segments of the body until he eventually just finished up with like just the head. So it's called Centipede Head, and that was actually pretty good. But it was the appeal of just being able to like make stuff up, that you could just conjure this stuff out the top of your head. It's kind of, you know this, right? It's kind of intoxicating. It's kind of, and it was easy. That's the thing. You sat down on the floor in front of your telly, or if you were, if you're a little bit upmarket, maybe you had a portable telly you could put on a dining table. And yes, these machines were constrained, but you could just start typing, right? And things would happen. And that was fantastic. And I don't want to get too kind of philosophical about, constraints setting you free, because I didn't think like that. I wasn't aware of that at the time. But that really was, this machine didn't do anything unless you made it do something. And it was easy to make it do something. That was brilliant. So, language acquisition is a complex business, and fluency doesn't necessarily confer understanding. And so and by we, I don't just mean me and Scott and Adcock and Woody and Pagey. I mean, and that cohort of, that wider cohort of teenage boys mainly. We were fluent, but I don't think we really had understanding. So I don't know what sixth form provision is like in Norfolk now, but in 1985 it was grudging, at best you could say patchy. So simultaneously with leaving school, I moved up into Norwich. I don't know why I'm indicating over my shoulder like that, and headed off to Norwich City College, now, as you can see, funkily rebadged City College Norwich, and apparently merged with North Walsham College. I didn't even know who North Walsham is. Anyway, and I actually went there to study electronics, despite having spent like 3 years doing almost nothing in my spare time apart from programming Spectrum. I went to do electronics. And the reason for that is Scott and I went up for an open evening. I think we might have been in a room just sort of there somewhere, I don't know. And we met a man who was a systems analyst. And he described what his job was and how it was different and far, far more important than a computer programmer. And you could hear him kind of sounding out those capital letters. And Jesus Christ, he made both those jobs sound so boring. And so it put me right off programming. I thought, if that's what programming for work was, I want absolutely no part of that. So I went and did electronics. Did 2 years at City College, which was great. I loved it. And then I went to university. I did 4 years of electronics there. I loved that. And then I got a job doing electronics and I had a great time. And then I had to find my next job. And that was a bit of a problem because there's not a lot of call for people who can build stuff like this. This is a static vacuum mass spectrometer. This is at the one of the planetary science labs at the Open University, which is where I was working at the time. I didn't actually build this one, but this is a piece of kit that was in use when I was there. That's the only photograph I could find. Some of these boxes down here, I think that one there, it's a little vacuum or pressure meter, and some of this switchgear up here, I think I built. This photograph was taken in 2011, and I built this stuff in 1992, I think. So you do a lot of kind of very boring, well, ordinary electronics here with your switching, and you learn how to make very, very high gain amps, like 10 to the 10, 10 to the 12 amps. But there's not a lot of call for people who can do that. And all the jobs had been taken by my predecessors at this job. And so I ended up getting a software job because I did have to write, I could write a bit of software, and, I thought, well, I can do some software. Anyone can do software. Not anyone can do software, but if you can do software, you can do anything. I think that's one thing. So I got a job writing software, and accidentally after that became a contractor and went from job to job like you do. And I was kind of okay at it, you know. But I did carry around this kind of, for quite a long time, carried around this snobby idea that because I'd done an engineering degree, I was bringing a certain rigor, you know, and discipline. And I, you know, I was fine at it really. But then, where are we? Let's go back to there. So that was that. So that's kind of, you know, I finished up in software kind of by accident. And I was doing all right at it, but, you know, I was just kind of ordinary, I suppose. And so 1998, I was working, I got a contract out in Germany, and it was one of those enormous projects. It had about 200 people working on it, and the whole thing being planned out over like 18 months or 2 years or something. And it was rubbish, really. There was this big feeling of kind of permanent crunch all the time. So I was one of about, there were maybe 12, 16 of us who were weekly commuting from the UK, and we'd fly out on a Monday morning and get to the office about 10, and we'd leave at 3 o'clock on a Friday, and we'd work between 45 and 50 hours between those two. We lived in a hotel across the road, get up in the morning, have breakfast, walk across the road into the office, start. And you went home, and then we get pissed up in the evening. And it was like being an Alvida's own pet, but better paid. But somehow, and I don't remember how, but possibly through Jim Copeland's column in the C++ report, I don't know, I found out somehow about the C2 wiki web. Now, these days, everybody knows what a wiki is, but back then, that was the first one, and it had just been invented by a chap called Ward Cunningham. And it was this open website, editable by anyone, powered by like this many lines of Perl. And for a while, it was absolutely red hot with conversations about software. And I think Cunningham had been involved in design patterns, or was involved in design patterns, which were the big thing, were very fashionable in the late 90s. So the original Gang of Four book, the design patterns book, came out in 1995. And there have been all kinds of conferences organised since. There was a pattern language programming design conferences, which were, and a series of books published from the papers from that. POSA, pattern-oriented software architecture, a series of books from that. And Cunningham had sort of developed this wiki, it's WikiWeb, as a way for collaboratively creating, providing a place where people collaboratively edit design patterns. That's the kind of thing you get for free with Google now, you know. So there were lots of people who are very well known, active on this website at the time. Ward Cunningham himself, Jim Copeland, Kent Beck, Kent Auer, and as well as patterns, the conversation kind of widened out, and what starts to emerge on this wiki is extreme programming. And Kent Beck and a chap called Ron Jeffries, they basically defined extreme programming, defined XP together, and they kind of mapped it and worked it out while they were working on a thing called the Chrysler Comprehensive Compensation Project, which is a payroll project, which doesn't sound very exciting. It doesn't sound like a place where software process innovation is going to happen, but it really did. And I'm guessing a bit about their kind of relationship, but it's almost like Kent took the lead, and Ron was kind of the, I don't know, like the coach or the mentor or the advisor. Certainly when they talked about it, when they wrote about it on the C3 wiki, like Kent would make some kind of relatively bold statement. And then it was like Ron Jeffries who would provide the kind of the exegesis, you know, it was like, and it's, I don't want to say, you know, it was like handing down stone tablets and then interpreting the runes written on them, but it was a little bit like that. You know, which isn't to say that Kent Beck can't be subtle and compassionate and that Jeffries can't be to the point, but that was the kind of relationship they had. And, you know, Martin Fowler was on there doing the work that led to his refactoring book. Like I say, Jim Copeland was there and he was obviously disagreeing with everybody. Michael Feathers was there. And there was these huge conversations going on, and Beck and Jeffries were, for example, when they describing test-first development or test-driven development, it was like, we take that for granted now, but then it was people's minds were just like, oh my God, they were aghast. They were staggered. Like, the tests first? What do you even mean? Maybe that's all right for you crazy small talk guys, shipping your old VMs off to people, but for us people in proper languages like C++, I don't even know if we can do that. Because you can. I mean, Michael Feathers demonstrated that almost immediately, but we, you know. And somehow I was there and some of the other guys I was working with were there, but not, it wasn't like a huge community there, but I don't know quite how we got in there, but we were there and we were participating, even if in a small way. And that actually, being able to be involved in something like that, it kind of really, for me, gave my self-confidence a real boost, right? That actually, I could say things to these luminaries and they didn't go, sorry, who are you? You know, they would actually go, oh no, actually that makes sense. Or sometimes it makes sense. But the thing that really, really excited me, there was this idea of extreme programming and the principles that Beck and Jeffries were outlining, and it's basically, if we take the stuff we know is good and we dial it up as high as we can, right, then that's got to be even better, right? So if code reviews are good, then we'll review the code all the time. And if short iterations are good, let's collapse the iteration right down. So like minutes. And if architecture is important, then let's make architecture something that everybody does. That's what refactoring is, right? You're improving the design all the time. Yeah, if integration testing is important, let's integrate as often as we can. Let's test several times a day. And it really spoke to me about what was important. And you know, the code was important. And if you didn't write any code, you didn't have a project. But you have to do the right code, and it has to work. And XP doesn't necessarily mean you deliver the right thing, but you'll deliver the wrong thing for less time. And that idea at that time, it really changed how I saw the world. And I tried to kind of put those principles into practice, even though my then employer didn't actually want me to. And even though I didn't fully understand the principles that we would, but I tried, and doing so made me a better programmer, and I did better work. And even if my employer didn't know why I was doing better work, they realized I was, because they gave me a fucking great pay rise to stay on. So that was kind of that's kind of external validation, I suppose. And when Kent Beck published his book, let's get that so you read it there. I was at the front of the queue to get this. It's actually slightly unfortunate because then there were like 1 million extreme programming books all published, sort of one after another. And they're not all great, actually. But embrace change, excellent. And I really enjoyed this one as well, which is, surprisingly enough, Ron Jeffries' book. And XP wasn't the only game in town, of course. There were lots of other things going on at the time. The Pragmatic Programmers book came out about the same time. Jeff Sutherland and Ken Schwabel were working on Scrum at around the same time. Alistair Coburn was working on Crystal Clear. Jim Highsmith was working on adaptive software development. And there was this big kind of software development mood going on, right? And it was kicking back against exactly the kind of project that I was working on at the time. And that all kind of crystallized in 2001 when all these people and a few others got together in a place I think called Snowbird, because Americans have weird names for places. And they all got together to draft the agile manifesto. And there's not really a lot here to argue with, right? We are uncovering better ways, so we don't know, but we're finding out better ways of developing software by actually doing it. So we actually have to write some software and helping others to do it. So it's no good if I'm really brilliant, but my teammate here, I don't tell him what's going on. We've all got to go together. And through this work, we've come to value interaction. You've heard this stuff, right? Individuals and interactions over processes and tools, working software over comprehensive documentation, still controversial, customer collaboration over contract negotiation, and that, we had some of that. Anyway, and responding to change over following a plan. And that's all very laudable. You know, that is to say, well, we value the items on the right, we value the items on the left more. It's all very laudable, but we could argue that this thing, this agile manifesto, is the point at which agile acquired like a capital A, and like permanently acquired a capital A, and all went wrong, really. Maybe we never should have come down from the trees. If you haven't read Embrace Change or The Pragmatic Program, I'd really recommend them, particularly actually if you've come into programming subsequent to this, because they'll help you understand why many of the practices which are just kind of commonplace today, why we try and do them, rather, because if we just do them, if we just perform, you know, wave our hands like this and maybe the airplanes will land, then we're not, you know, if we can't challenge the reason for a thing, then we're not actually going to improve. So I would recommend those. Some of the other stuff, not so much. Anyway, over time, you know, the excitement dies down and the gang breaks up, people go off and do different things, and the web becomes a different place, and the whole kerfuffle kind of dies down. But the world has changed, the world more generally, and for me personally. It was what I needed then, right? And it's what I've tried to do ever since. I mean, with various degrees of success and a number of degrees of failure, and the changes it's prompted me to make, it's not an exaggeration to say it changed my life. I do better work as a result, so I'm a happy person. And I've met and got to know a number of you wonderful people, and that's enabled me to do all kinds of interesting pieces of work I wouldn't otherwise have done. So 98 turns to 99 and 2000, and we're into the new millennium in a kind of, you know, profoundly changed state. So what about the asteroids, Jez? So a couple of weeks ago, about 6 weeks ago, now 5 weeks ago, 6 weeks ago, I saw this tweet. Folks, this is a really fun series. This is Cheap Hill, who's another agile coaching type. Folks, this is a really fun series. Ron does a really good job of providing a commentary reel to his process. Now, ordinarily, I suspect if I hadn't recognized the name Ron Jeffries in the bottom there, it probably would have just passed me by. But I did recognize Jeffrey. I'm deeply grateful to Ron Jeffries for the work that he's done. So I clicked through this thing, and I start reading. He's on Asteroids 14, so he's written 14 articles at this point. So I click through and I start reading, and this is. It took me a couple of days to get around to it, but then I did. I was like, "Fuck it, this is great. This is just so much fun." So that I tweeted this myself. I said, "Everyone, chums, go and read these articles." And then almost immediately afterwards, I tweeted this. Look, and I don't know why it's doing. I got a little twirly thing in the middle there. Look, and I got super excited. And then a couple of days after that, I had this little spaceship flying around on my Nexus emulator there. And then a couple of days after that, I had something that looked like a game. I don't know if you can hear it. There we go. And then because no good deed goes unpunished, oh, I've broken something. Oh, I don't know. Mucked up my slides. Anyway, because no good deed goes unpunished, I finished up talking to you guys. So what Ron Jeffries is doing is he's writing a version of Asteroids, the sort of, classic 1979 version Asteroids, for his iPad using an environment called Codea, and which is a Lua-based environment. And as far as I can tell, I'd never heard of it before, never used it. It actually runs on your iPad, and you sat there and you type the stuff into your iPad, and then it runs around. And he was writing these articles, he was describing what he was doing and the decisions he was making, and he's trying to test drive a very graphical application. I mean, test drive a game, and that was an intriguing idea, because I mean, test driving anything that's graphically heavy is difficult. And he was, and he was sort of succeeding in some ways and not in others. But where have I gone? I've lost my thingy. Never mind. What if I press that? There we go. So at the end of each article, he would include, as the code got bigger, he stopped doing this, but at the time he was including all the code that he'd written at the bottom of the article. And here's a little function to draw the spaceship, little triangle spaceship. And you can see moving over here, and there's some stuff, like it's just a very simple little triangle on the sides here. That you can probably work this out. But these two lines here, these two lines, you know how at the end of Murder, She Wrote, or some kind of similar light murder mystery, somebody says something offhand, and that they have a little flashback sequence where the detective remembers all the clues, and they all kind of fit into place like a jigsaw spontaneously assembling. Well, when those two lines, right, gave me that same sensation, but I didn't know that I was trying to solve a mystery. It's like suddenly all this stuff I knew, but which I'd never put together, which I wasn't even trying to join up. Suddenly it was like the planets aligned and a pink laser beam shot out of space into my head. And I was away off to my, Android Studio, and I'd started programming. So I've got no idea what my next slide is. There we go. So that translate and rotate thing, that keyed off something. So one of the things I've been working on for a few years now is this Android application, Focal Streets for Android, which is a sat nav for cyclists. I just do, I don't do the routing part, that happens in Cambridge somewhere, but we've got this nice little Android app. And I've been adding a new feature. So we do kind of live navigation, but only very recently got it so that it, rotates the map to the direction you're heading, which I'd never thought was a big thing, but apparently lots of people get very confused if they're heading south and the map is oriented north. But anyway, so I was working on that. And here's a little film of that. Look, so I'm rotating as we rotate the map, or rotate the phone. You can see it's, the map rotates underneath it. And the particular bit I was working on was just this little, this map rotation is provided by the underlying OSM Droid libraries. If you're doing any mapping on Android, OSM Droid's excellent. But I've got this little compass icon, which obviously I always want to point north. And we've got a little button widget here. So that's like a little control. And we've got a little SVG graphic that we're popping on top of it. And in order to get that rotation, what I do is you query the sensors on the phone, either the compass or the GPS, depending on whether you're moving or not, and say, where's north? And it tells you, and you rotate that much in the other direction. And then you slap your SVG on there. So there's a call you can make on the graphics context to rotate it. And there are also things to what it calls translate, which kind of offsets the origin, moves the whole surface. And then you draw on the top. And the realization then, I thought, well, hang on, you know, that if these things apply just to individual little lines and points, not to entire SVG. So it kind of, it's like I knew it, but I'd never thought to apply it. So my first little ship thing looks like this, which is almost the same, right? Even though we're on entirely different platforms, almost the same. It turns out the canvas is the surface that you're drawing on, and it can have had a number of different translations or rotations applied to it. So what you often do is you save the current state, then you do what you're doing for whatever your little operation is, and then you restore it. So you stack these things up and you unstack them again. So it's almost exactly the same. It's translate. So I say, where do I want to draw it? Let's move it over there. And then I'm going to rotate it so it points the way I want. And then you draw it. And that way, my little shape, I don't have to manipulate these coordinates. I can just let the graphic surface do it for me. So this is defined as like a little triangle with a, well, it's not quite a triangle, it's a little dart shape. So all that stuff has just gone away. And you think, oh, that's great. And so that was one part of it. Another part is that all modern GUIs are reactive. So I mean, I say modern, all GUIs since about 1990 have been reactive. So you have a window, and the window within that has a number of child windows, whether you call them windows or widgets or controls or whatever, and they're arranged in kind of a hierarchy. And if there's a mouse click here, you raise an event and you deal with that. And if this bit gets pasted over by that, you get another event that says just why do you put that? There we go. You just got to redraw that bit there. And you get told, the program tells you when it wants something done. As we saw back in 1982, games tend to be much more imperative, and they tend to be in this very tight loop. Airplane. So, you have a very tight loop where you say, I want to update my state. Is the key pressed? Move that way. Is this key pressed? Move that way. And then I want to draw it, and then I want to go around again. And then I want to draw it, and then I want to go around again. And the Codia environment that Ron Jeffries is using kind of abstracts a lot of that stuff away. So what it seems to be doing is it draws you, instead of calling main as your entry point, it calls a function, it's looking for a method called draw, and it calls draw as often as it can in a very tight loop. And you do get certain events. So you get like the touch events, as people waggle their fingers on the screen. But you see those events come in, but mainly it's sitting in a tight loop, and it's calling draw. And you have to do, you're updating your drawing in that one method. And I thought, well, hang on, I can do that. So we're kind of turning some of it inside out. And I said, well, I can do that if I can get a window that fills my phone screen. Fills the whole screen, and fire up like a thread in the background that just wangs around as fast as it can, then I can do that on my hardware. And so that's going to invert that loop for me. And that's how I got that twirly thing. So there we go. This is the core of our little thread loop. So while it's running, I'm going to do it. I have separate updates and draws. So I'm going to update everything, update the whole world, all my little objects, however many there are. And then I'm going to draw them. And then I'm going to go around again. and I'm going to draw them, I'm going to go around again. So that was just like the second part. And the last part was a little maths. So vector addition. So I'm sure you've all done stuff like this. Here we are, figure 2OB is produced, it's extended to D, so that BD is 2OB and OA is extended out. So this is 2OC, expressed in terms of A and B. These are vector A and vector B, because, you know, mathematicians hate names. What is OD? What is BC? You know, so there, BC is like, well, it's that one, then it's that one. And, you know, so we've got some vector addition going on here, right? And the way you get those lovely glidey effects in a game of Asteroids without having to do too many sums is through vector addition. So if, for example, if we imagine that I've been pointing the wrong thing there. If we imagine that our little spaceship is traveling along this line, but it is pointing back in this direction, right? So it's traveling in this direction, but it's pointing in that direction. When the bullets ping out the front there, the bullet is going to have the velocity, the vector of the bullet is going to be this plus this. So they are going to travel in a lovely line along with the ship. And if the ship is accelerating, they're all going to bunch up a little bit as it accelerates, because you get a little Doppler effect. And if you turn around and go the other way, they're all going to kind of spread out again. So you get this really nice, really, I don't want to say realistic, but you get these really nice effects for not a lot of maths. So if we jump across, let's look at the code. If I can find the right thing to press. If we jump across to Android Studio, so that very first thing that I posted, it was this one here, twirly, and this is it. This is the ship. There's just that ship in the center of the screen, just twirling and twirling and twirling. So when I get an update, I'm just going to increment my little angle. And when I draw it, as the angle is increased, it's just going to rotate around. And just that, this is it. There are what? How many lines actually mean anything here? Like 10? This was it. I got this and I was away. I was absolutely away. There's my little thread that's setting it running. This and that and the ship, they were the two things that really got me going. Because Codia does something to maintain a steady refresh rate, so it polls at a consistent rate. I'm just letting this wang around as fast as it can. And so I've got a little bit of scaling related to the, I basically want to work out the frame rate that it's doing and kind of scale it back. But this is it, and it just, you know, wangs around as fast as it can. And then from there, it's just really straightforward to build stuff out. So once you've got it twirling, then you can start it moving. So you've got the angle that you want to move. This is weird, actually, right? That some of this, normally in computing, we work in radians all the time. Some of these graphics calls are in degrees, which seems weird. So we've got our rotation, and we've got a direction that I want to travel, and a magnitude, speed that I want to travel. So each time, just update stuff a little bit. And we know from Pythagoras and your right angle triangle that a vector like this, you can work out, it's a hypotenuse of triangles. So you can work out the x and y deflection, and that's what's going here. And then this stuff at the end is to wrap it around. And it's all very longhand, but that got my thing just traveling around. And I was like, okay, well, can I hook up a touch event in the same way as the Codeer environment is doing. I mean, bear in mind that I don't have Codeer, and I'm working this all out just from the code that's published, right? Turns out that actually, yes, you can. So the touch events come in on the view in Android. They come in on the view that you touch. So I've got a view that's filling the screen, the window that's filling the screen, and the touch events come in on that. And if I want, there are kind of levels of event that you can. So simple touches are all kind of built in. If you want gestures or multi-touch, you've got to do a little bit more work. And if you're writing a game for a tablet, something that's maybe something that's that size, you can probably put some on-screen buttons on there without losing too much of the playable surface. But you can't do that with something this size. If I put my finger on there, I'm just playing in a tiny little space in the middle. So what I wanted to do was have a control scheme where I would just kind of just swipe it around. So if I swiped my finger in a direction, I want the ship to swing itself around to point in that same direction. And if I tapped it, then it would thrust. So you need to hook up what's called a gesture detector. And most of the events you can actually ignore, the flings and things. Weirdly, the swipe is called a scroll event. And you get a number of parameters on here. One is, these are quite detailed, and they'll tell you things like, if you've got a multi-touch thing going on, which of the touches actually did the swipe? And I'm not interested in that. All I'm interested in is this bit here, the offset, which is what direction did they swipe? Which way did that finger move? And it gives you the X and Y offset. And then we can apply that GCSE level maths to go from our X and Y offset back to a vector and back to an angle. So it's a bit of a mouthful because these things arrive in floats and the values we want are in, the functions want double precision, but so that's a bit of a mouthful. Basically, this is, you've got your adjacent and your opposite, so you can work out, you can do the arctangent. And then because that seems to be normalized to portrait mode, but if you're playing in landscape, then everything's squigged around the wrong way. I got this by experimentation, but basically you have to juggle it a little bit to put it into the right quadrant. You can't just use raw values to get them. So that's what all this stuff is down here. And then you can just bang it onto, you can just call a little event on your own, in this case on my ship, and say, well, that's the angle that I want to point to. And when I'm updating, and say, well, where is it really? What's the difference? And just start to spin it around. And you can get a little bit sophisticated and say, well, if it's a big difference, move really fast and then gradually just slow down as you come in. Oh yeah. Obviously I was experimenting at the time. And then it's been really fun actually. So I got really excited and I started hammering out on this code and writing this stuff. And for some of the features, so Ron Jeffries is writing quite a close version of Asteroids to the point where he's been reading some of the 6502 assembler in the original game to try and work out how some of this stuff works. And I've been doing a kind of asteroids-y type thing. So we haven't been exactly parallel, but for some of the stuff I was kind of running ahead of him. And for some of the stuff he was running ahead of me. And then every now and again we'd kind of unconscious, well, obviously he didn't know what I was doing, but we kind of synchronize. And it's been interesting. Some of it's been interesting in the way that some of the changes that I've done, because I'm working here in Kotlin, which is, I mean, it's not as everything must be a class as Java is, but it's still quite keen on strong types. And he's working in Lua, which is significantly more relaxed. Some of the choices that we've made, we've ended up in similar places, but I've made some of those, I've moved in that direction perhaps earlier, because the language likes it like that. Whereas his language has been much more relaxed. It says, yeah, you can have half a dozen different things that aren't really related and just put them all in this one collection. Yeah, so where are I gone? So let's do it, I don't know. Hang on, let me try and do this, do that. And so I just kept on going. And actually, one of the weird things is even my kids thought this was all right, which for those of you with kids, it's a big achievement, right? So here it is. This is running on an emulator, and it's extremely hard to play with the mouse, but we'll have a go. Don't know if you can hear that. Is that making any noise? No, it doesn't seem so. So there we go. And there we go, it's twirling around. Ah, disaster. Because Alex put a spaceman on the promo graphic for this talk, that's why that little spaceman is floating around there. Oh no, he's gone. He's gone. That's why my little spacemen are floating around there now. I've got to try and rescue them. But it's been really great to kind of do something that I did as a kid, but with the knowledge that I have now. So for these kind of animations and stuff, right? The ship animations or the ship transitions, I've got a little state machine in there, so I don't clutter myself up with like 5 levels of if I'm flying, if I'm doing this, if I'm doing the other. Just put a little state machine in, it all just pops out. We can do these lovely graphic rotations without having to do any sums, because the canvas will take care of them. We can do these different sizes of graphic just by saying, scale this up and scale this down. And it's just been great. And I would never have come to this if 20 years ago, you know, I hadn't chanced on the C2 wiki. And if 20 years before that, I hadn't had a Spectrum sitting in my front room. So, you know, sometimes life really does give you those little circular stories. As is traditional in this kind of talk, this is where I say, if you are interested, you can, I've got to go back there we go. You can find this on GitHub, of course. Here it is, Jez Higgins /swoop. Or, and this is an exciting world premiere, if you have an Android phone that is, I think, running Android 9 or 10, you can install it from Google Play. And it would be lovely if you did, because we're still making up stuff and adding new levels. And it gets really hard about level 9. But, you know, if you could get a better high score than my son, then that would be great. And he'd be doing me a favor. I think I've run out of things to say. Thank you for your attention.
Thanks, Jez. That was awesome.
Thank you.
It's so weird talking to like a completely silent or kind of no faces. I feel for you.
Yeah, well, you know, sometimes I just lie awake at night and talk to the ceiling. Let me see if I can get some useful URLs here. So,
then tracking them down to throw them into YouTube.
Yes, hang on. If I go over to this other computer that I've got here, there we go. So I would really suggest you do go and read some of these articles that Ron Jeffries has written. He's up to about 60 now. He published number 60 today. And I know that's a bit of an ask to say, oh, fuck, I pulled that up, to say, go and read 60 articles. So if you're not quite as enamored of it as I am, that's fine. But I would go for number 59 as a starter, because I thought that was really quite affecting, actually. He's coming up to the end of the sort of the project, really, and he's reflecting on some of the stuff that he's done and how he's, some of the experiments he's tried that have worked and not worked and things. And it's really we could all do with having that kind of level of insight, really. It's quite really, it's quite a difficult thing to achieve. And you've got to practice, I think. So yes, sorry, I've just fired a load of links into YouTube there. Hopefully those work. Hopefully, well, no, they don't, because I've copied them wrong. But anyway, you get the idea.
I've sent a couple over. I've got Ron Jeffries up on my screen right now, looking at his asteroid articles. So I can't promise you I'll make it, like you say, through all 60, but I'll certainly dive in.
Yes, there we go. This one here, number 59,
Yeah.
more drawings. And particularly what he talks about is there was a bit of work he'd done that he was a little animation that he was particularly pleased with, but actually didn't always work. And he was talking about the importance of being able to recognize that sometimes you've got to stop and start again. And you might be particularly attached to this bit of code and particularly pleased with yourself, but sometimes like you said, you've got to kill your darlings and start again.
Yep. Feeling I'm oh so familiar with.
So let's go back to this.
These transitions are amazing.
That was good. I hadn't noticed that one.
All I really wanted to do was, when I went back to 1982, was to go down a time tunnel, and then I spent an inordinate amount of time trying to get that, and I was quite.
You've learned things along the way. That's the fabulous part, right?
Sorry, say again.
I said you learn things along the way in your pursuit of just a little warp through time machine.
That's
You've got complete control now.
Okay, let me, here we go. Hang on. Let me put that link over here. There we go. Oh, right. Any more, or shall I let you all go and have your tea?
When's the iOS version coming out?
Never. Several years ago, I can't remember exactly how long, 5 or 6. I did think that, because there were, and this is still largely the case, I think, there were iOS developers and there are Android developers, and they are largely separate tribes, right? And there are people who do sort of stuff in the middle like Flutter, but don't seem to be many of those. And I did think that maybe I should get myself an iPhone and kind of dual skill, right? And so I took some advice from my friend Phil, and he said, yeah, you need an iPhone and you'll need a Mac. And I kind of, I thought, oh God, okay. And I spent a load of money, and the Mac's all right. And I've got it here and it's still working, and it's hardware wise, it's, it's probably the best laptop I've had. The Mac OS is anyway. But this thing, the iPhone, I really hated it. And like for 18 months, every time I got it out of my pocket, I thought, I just couldn't forget how much money I'd spent on it. I never, I don't know, I'm normally quite utilitarian about these things, but I really didn't like it. So I never did write any iOS code at all. So there won't ever be one. But
Down to one of us to port it then. Down to one of us to port it.
Yes, or you could, you could just get Ron Jeffries' code. I think what Codeer can do is actually produce an executable, because I think basically you because Lua's like really embeddable, right?
Yeah.
So I think basically they've got like a framework that the Lua is embedded into, and you just package the whole thing up, and then you can publish that, I think.
Cool.
It's And there's I did find, so that's Codia. And I did find an Android, similar looking Android thing, which looked quite fun. I think it was called Fonk. Which I haven't got queued up here, but yeah, so a similar kind of thing. But yeah, it looks Codia looks really fun actually. I think it'd be good with kids actually. You know, of that kind of age that I was, that kind of, 11, 12, 13.
I played around with it a few years ago. I'd forgot it was still going actually after we installed it.
But yeah, because I know it might be, I don't know whether it wouldn't be the natural progression from something like Squeak, but it would, not Squeak. What's the one they use in schools?
Scratch.
It's not the sort of the immediate next step, but it seems, doesn't seem like too far of a gap, because you can still, because being able to draw stuff on a screen is really cool, right? And if you want to do that in Python or something, you've got to go through, even something in Python, you've got to go through however many lines of setting up Pygame before you can draw a thing. But with that, you just put something in the method called draw and it gets drawn. So, I think that would be pretty
Even
cool.
I've gone Scratch Swift with my daughter. Codia might be might be an interesting middle ground, because Swift is a bit of a. We've got the Swift playgrounds, which is actually very, very good, very well done. But I think there's only so much you're going to be able to do before you're like, right, so you can program in Swift. Well done.
Yeah.
Yeah, just being able to put stuff on the screen, that was why the Spectrum and the ZX81 and all of those things were so popular.
Yeah. Because you had to, right? Because otherwise it was a really expensive, it wasn't even heavy enough to be a doorstop. Well,
you could put swear words in Woolworths.
Sorry, say again, Steve.
And if you were very fluent in it, as you were talking about earlier, you could do it to put swear words up in Woolworths.
Oh, yeah. It was
How we
worth.
find out while Woolworths went under.
Yeah, it'd be the highlight of his after hour and a half on the bus into Norwich, going to WH Smith's, 10, print shit, 20, go to 10, run out again. Absolutely hilarious. I can see you laughing, Alex, but I can't hear you, which is unnerving and slightly creepy.
Silently laughing. Sorry, it is a bit creepy, isn't it? I was just trying to work out whether or not my microphone is broken. Oh, heard that loud and clear.
I don't think it is.
No?
If that was your microphone, it wasn't broken.
Well, there we go. Fixed again. I just need a microphone arm for it now. Right. Unless there are any questions in the YouTubing live chats, I might just drop the YouTubes, so no, there isn't. So I'm just going to wave goodbye to the YouTubers and hit the button. Thanks for joining us. Subscribe and like and all of those fun things. Bye-bye.